In the year 1600, the world was covered with many sources of knowledge regarding about understanding how heavenly bodies move. Many people believe in geocentric model, by which states that Earth is surrounded by many unchanging stars. As years passed, the perspective of geocentric model was changed by one of the Catholic priests or an astronomer named Nicholas Copernicus. He introduced to us the model of heliocentric, which states that Sun is the center of the solar system. By that idea, the perspective of heliocentric model really changed the perspective of understanding how the universe or the planets move. As years passed by, in the year 1609, another astronomer revolutionized the understanding of how planets move. Today, I need you to buckle up and prepare yourself because we're gonna understand the movement of the planets. In 1609, another astronomer revolutionized the understanding of how the planets move. Johannes Kepler. When Nicholas Copernicus introduced the circular orbits of the planet, some of the data made by Johannes Kepler didn't fit by his own equation. That is why he introduced one of the most revolutionized understanding of how the planets move: the three laws of planetary motion. First law of planetary motion. It states that the orbit of the planet follows in an ellipse, having a sun one of its focus. You can draw one by using a loose string, placing a pin at its endpoint, and attaching it to a flat surface. One of its focus is the placement of the sun. Second law of planetary motion. It states in a simple manner: equal area and equal time law. When an object reaches the farthest part of an elliptical orbit, what we call as aphelion, the velocity of that particular revolving object will decrease, and its area that it covers will be the same when it reaches to periphelion. But it only varies in one thing: its velocity will increase. It will cover much area and also much velocity. Kepler's third law of planetary motion is intriguing, but yet it's true. It states that planets revolve around the sun the distance behind it, when you raise it to the power of 3 over the time it takes to revolve raised to the power of 2 will be the same to all planets. Sounds weird, right? But yet it's true. When you raise to the power of 3 the distance of Earth to the sun and divide it by the time it takes to revolve raised to the power of 2 will be the same to the distance of Jupiter to the sun raised to the power of 3 divided by time it takes to revolve raised to the power of 2. And it's obviously correct. 2.5 times 10 raised to the power of 19. By the idea given by Johannes Kepler, it established the fundamental understanding of how the planets or the whole universe move. Thanks for watching and see you next time.